Okay, now I'm gonna get started. Okay. I just want to check quickly before we start. Has anyone been looking at like the videos of previous lessons on YouTube? Anyone who's missed classes and stuff like that? Does anyone here put up your hand if you've taken a look at those at all? Okay. Do they work? Is everything okay with them? The links all work and everything? Great. This is the first time I've been doing that, so I just want to make sure that that everything's fine with those. Again, the video quality is probably not going to be very good because this is my laptop's webcam, and I try to make sure it encompasses this entire board, but there's no way I can get the board and the screen. So that's why I also have the slides available. Hopefully that's enough. Oh yeah, and I need to turn my wireless off so it stops doing that. Okay. Okay. So, okay, what's on the agenda for today? So the first thing to mention, I didn't get any minus point cards to be written on it last class, so I don't have any minus points to do today. But I am going to do a little bit of a review of what we did on Friday. One of the reasons is because, again, I didn't get a chance to go over the solution to the group problem. So I'll do that to give class a little bit of review. And there's also one last slide from that section 1.6 that I didn't get a chance to go over because of the lack of class. So I'll go over that as well. And that'll be the first little bit of class, therefore we'll do a little bit of a review of what we did on Friday. And then I'm going to be starting Chapter 2. Now, Chapter 2, like Chapter 1, is designed to be mostly review of stuff that you've seen before, stuff that you should have learned in high school or in previous math courses here if you've taken like Math 196 or something like that. So again, I'm going to be going through it fairly quickly. 2.1 is 100% review, fairly basic, fairly straightforward stuff, which is why I only have 15 minutes budgeted for all of Section 2.1. And the reason is once you see what Section 2.1 is, you'll be like, okay, I understand why it only takes 15 minutes. Then I'm going to be starting Section 2.2 today. I will get to all of 2.2. Section 2.2 is about graphing equations and certain different properties of graphs that we can talk about. And that's what we're going to be going over later. And yeah, I got through a little bit of 2.2, but I won't finish Section 2.2 today. My goal is to be able to finish Section 2.4 by the end of the week. If I can get through to 2.4 by the end of the week, it means I'll have all of next week to do 2.5, 2.6, and 2.7, which is all harder stuff in Chapter 2. And then the week after that is going to be the first test. As I mentioned, the first term test is happening 2 weeks from this week. It's either going to be on the Thursday or the Friday of that week. At this point, I'm enough behind where I want to be that I definitely don't want to have it on the Tuesday because I may need to use the Tuesday to finish off Section 2.7. So I want to make sure it's not going to be on the Tuesday, but the Thursday or Friday are both options. One of the things I want you folks to think about between now and Thursday is whether or not you prefer to have a test on the Thursday or the test on the Friday. And in Thursday's class, you're going to have a vote. That's whether it'll be on Thursday's class or the Friday's class 2 weeks from now. Again, that's the last week before the break. Oh, let me just break down those dates for you folks so that you have an idea of the options. So the options for the test are either Thursday, February 6th, or Friday, February 7th. So again, look at your schedules, think about those 2 days, think about which of those you'd rather have the test on. And we'll have a vote on Thursday's class as to which of those days we'll go with. Great. Okay. Any questions? Oh, a couple more reminders. I'm going to do them now because otherwise I might forget. There is the handed assignment that is due, or the written assignment that is due on Thursday. I handed it out to all folks last week. It's also on the course webpage. If you do not have a copy of the handed assignment, I probably still have some extras in here. So put up your hand if you want one, or else they're also on the course webpage if you want to find them there. Again, due Thursday. If you don't get it done in time for class, you can also send it to me by email anytime before midnight that night. Really, when I say before midnight, I mean before I start marking them Friday morning. So I don't know what time I'm going to start marking them Friday morning, but whenever I get to campus Friday morning, that's basically when we'll be starting marking them. So try to make sure that it's to be by then. If you send them to me at 2 a.m., they'll still be on time. The midnight is really just saying, before Friday morning. And Yeah, and what else was I going to say about that assignment? Yeah, if you have any questions about it, again, I've got office hours on Thursday. It's the best time to come ask me questions or send me an email. I can definitely give some pointers if folks are completely lost. And the other thing is, just before class, I created a new web assignment. It is going to be due, I decided, because I didn't do it until today, I usually try to do it on Mondays. This one's not due until Saturday at midnight rather than Friday at midnight, so you've got a little bit of the weekend to work on it too if you want. Again, usually, my thoughts was usually to be due at the end of the day on Friday, but I might actually keep with Saturdays because it doesn't make a difference for me, to be honest, and it gives you folks some of the weekend to work on them. The next quiz will be coming up next Tuesday, and I'll talk a little bit more on Thursday and Friday's class about the next quiz. Any questions before I move on to the review of stuff from last class? Oh, yes. Jacqueline. Handwritten is fine as long as I can read it. I'm not. If anyone here is planning to be a math major, there will be a point at which people want you to type math assignments. Typing up math is difficult. And if you're sending it to me via email, it's fine to scan it or take a good quality photo of it. Again, I don't need you to type it if you're sending it via email. In fact, generally I prefer handwritten stuff because most people are not able to get nice-looking mathematical formulas out of their computers. There's a couple different programs that'll do it, but standard word processors won't. So, yeah. Any other questions? Great. Okay. So this is the group problem from Friday's class. This is an inequality. And one thing to mention about this inequality is I've already factored it for you. Now, if it was just a linear inequality like this, 4 minus x is less than or equal to 0, I could solve it by adding x to both sides. Because this one is not linear, because this is actually a polynomial if you expanded it. If it's a polynomial inequality or a rational inequality, what we're going to have to use to solve it is that thing that's called a sine table. So the key thing here is to think about the inequality. As that whole thing over 1, right? So it's got basically a numerator, it's got a denominator. So the first thing we look for are what are called the zeros of the numerator. Where is the top 0? Well, the top is 0 when x plus 2 is 0. What happens at x equals negative 2? The top is 0 when x minus 1 is 0. What happens at x equals 1? And the top is 0 when 4 minus x is 0, which happens when x is 4. So negative 2, 1, and 4, those are the zeros of the numerator. Now if I look for the zeros of the denominator, there are none. The reason is because the denominator is just 1. 1 is never 0. So there's no places where the bottom of this thing is 0. There's 3 places where the top of it is 0. And so those 3 places where the top of it are 0 are the places we're going to use to divide up our number line when we do the sine table. So you draw a number line, and the 3 places you're going to put on there, you're going to put in the negative 2, you're going to put a 1 on the number line, and we're going to put a 4 on the number line. And when we do this, this is dividing the number line up into a certain number of intervals. Where are my other colors? Oh, did I? Oh, here they are. So, we'll have one interval from negative infinity to negative 2, another one from negative 2 to 1, another one from 1 to 4, and I'm going to need to erase this guy to make more space. Another one from 4 to infinity. Right? So those are those 3 intervals. Right? Again, there's 4 intervals. There's 3 places where it's 0. That means if you cut the number line at those 3 places, there are 4 places left over. 4 intervals. So we make a table. What are we considering? Well, what are the factors here? There was an x plus 2, there's an x minus 1, and there's a 4 minus x. Again, one thing that helps when doing this sign interval is to think about what is called a test point in each of these intervals. Right, in the first interval, we could pick, for example, -3 as a test point. In this one, we could pick 0, because 0 is between -2 and 1. In this one, we could pick 2, because 2 is between 1 and 4. In this one, we could pick 5. And so what we're going to do here is we're going to do x plus 2 for each of these. -3 plus 2 is -1, which is negative. 0 plus 2 is 2, which is positive. 2 plus 2 is 4, which is positive. 5 plus 2 is 7, which is positive. We're going to do x minus 1. -3 minus 1 is negative. 0 minus 1 is negative. 2 minus 1 is 1, which is positive. 5 minus 1 is 4, which is positive. We do 4 minus x. 4 minus -3 is 4 plus 3, which is 7, which is positive. 4 minus 0 is 4, which is positive. 4 minus 2 is 2, which is positive. Now 4 minus 5, that's where we get a negative result. We get -1. And then the last row of the sign table is whatever the function is. Here it's x plus 2 times x minus 1 times 4 minus x. So I apologize for anyone sitting over there who this screen is going to get in the way of it. I'm trying to pull the screen back. X plus 2 times x minus 1 times 4 minus x. That's what should be in that last row. Actually, you know what I'm going to do? I'm going to write it again over here, just to show people what will be over there on the left-hand side that they may not be able to see depending upon where they're sitting. X plus 2 times x minus 1 times 4 minus x. So what this is really is this thing times this thing times this thing all multiplied together. So what we're going to do is we're going to take a negative number times a negative number times a positive number. Negative times negative is positive. Positive times positive is positive. Here we're going to have a positive times a negative times a positive. Positive times negative is negative. Negative times positive is negative. Here we have a positive times a positive times a positive. Positive times positive is positive. Multiply that by another positive number. It's still going to be positive. And here we have a positive times a negative. Positive times positive is a positive number. Multiplied by a negative, it gives you a negative result. So now the thing is, we want to know where this thing is less than or equal to 0. Well, it's less than 0, both those places where it's negative. So here and here, those intervals are good. Those are places where it's less than 0. Places where it's positive are bad. Places where it's not less than 0, where it's bigger than 0. Now it's less than or equal to, so we're also going to throw in all the places where it's equal to 0. This 4 is a place where it's equal to 0. This 1 is a place where it's equal to 0. And that -2 is a place where it's equal to 0. So everywhere it's equal to 0, when we write our solution, they're going to have square brackets. So we're going to have this interval from -2 to 1, but we're going to write it with square brackets. Because -2 and 1 are both places where it's equal to 0. We're also going to have this interval from 4 to infinity. And here, we're going to write the 4 with a square bracket. Because the 4 is a place where it was equal to 0. If that place was a place where the denominator was 0, it would not be equal to 0 there. It would be a restriction on the domain there. It would not be a square bracket. Does that make sense? Any questions about this? Okay. So I'm going to use this method to do 2 more examples. Oops. In the other slides. In the 1.6 slides, which are on the last slide of this. So let me just skip. Okay. So, one thing to mention is the procedure we've used so far has always been with inequalities that have a 0 on the right-hand side. Something's bigger than or equal to 0, something's less than or equal to 0, something's bigger than 0 or less than 0. If there is no 0 on the right-hand side, we have to make a 0 on the right-hand side. Because otherwise, we cannot compare that thing to 0. So, if we we don't have a 0 on the right-hand side, something like example 7, we first have to make a 0 on the right-hand side, and then we can proceed with the factoring and everything else. So here, in example 7, which I will start here, we start with 8x minus 15 is bigger than x squared. So the key thing is we want a 0 over here, which means we're going to subtract x squared from both sides. We get minus x squared plus 8x minus 15 is bigger than 0. So now we have a 0 on the right-hand side. Now we can start factoring. The first thing I'm going to do here is I'm going to factor out a common factor of negative 1. The reason if I do that, the thing in front of x squared will just be a positive 1 rather than negative 1. It will make this easier to factor. I'm going to have negative 1 times x squared. When I take a negative 1 out of positive 8, I'm left with a negative 8. When I take it out of negative 15, I'm left with positive 15. Then I've got to factor this guy, x squared minus 8x plus 15. I do two numbers and multiply to 15, add to negative 8. They turn out to be negative 5 and negative 3. And again, we sort of think about it as this thing over 1. So then we have to ask, when is the top 0, when is the bottom 0? The numerator is 0, when x is 5, and when x is 3. Right? X minus 5 is 0 when x is 5, x minus 3 is 0 when x is 3. The denominator is 0, never. So, in this situation, the points we're going to use to divide up our number line are going to be 3 and 5. Here's the number line, 3, 5. The intervals are going to be negative infinity to 3, 3 to 5, 5 to infinity. The test points, well, I could pick a 0 here, I could pick a 4 here, I could pick a 6 here. Again, if you can do it without finding test points, just being able to figure out, okay, it's going to be positive or negative, you can do that. But having test points is useful. Having things to plug in to see whether it's positive or negative is useful. So the things we're worried about are x minus 5 and x minus 3. So at 0, x minus 5 is 0 minus 5, which is negative. At 4, x minus 5 is 4 minus 5, which is negative. At 6, x minus 5 is 6 minus 5, which is positive. At 0, x minus 3 is negative. At 4, x minus 3 is positive. At 6, x minus 3 is positive. Now what we're interested in our final row, is we're taking negative x minus 5 times x minus 3. So we're going to multiply whatever those two things are together and then take the negative of it. We'll multiply it by negative 1. So we're going to do negative times negative times negative 1. Negative times negative is positive, multiplied by negative 1, we get a negative result. Negative times positive is negative, multiplied by negative 1, we get a positive result. Positive times positive is negative, or positive times positive is positive, multiplied by negative 1, we get a negative result. What we're interested in is, when is this thing bigger than 0? It's bigger than 0 when it's positive. It's not bigger than 0 at the other two places. So the solution here is this interval where it's positive. The interval from 3 to 5. Again, the reason I'm putting round brackets on there is because even though 3 and 5 are places where it is 0, it is not allowed to be 0. It has to be strictly bigger than 0. It cannot be equal to 0. So just the stuff between 3 and 5, that's all that counts. Any questions about example 7 here? Again, whenever you're solving inequalities, you always write your solution in interval notation, as an interval between one point and another point. Okay. Next, last example is example 8. So now this example is one where the algebra is going to be a little bit more difficult. Here we have 2 over 2x plus 3 is less than or equal to 2 over x minus 5. Now, in order to get this thing to compare it to 0, I'm going to have to subtract 2 over x minus 5 from both sides. So I have 2 over 2x plus 3 minus 2 over x minus 5 is less than or equal to 0. And then I've got to combine these guys into a single fraction. The reason for that is if it's not a single fraction, we cannot factor it. Right? You've got to factor the top and bottom to figure out where's the numerator 0, where's the denominator 0. We cannot factor if we have two separate fractions. So I'm going to multiply top and bottom of this guy by x minus 5. I'm going to multiply top and bottom of this guy by 2x plus 3. When I do that, the top of this guy will be 2x minus 10. The top of this guy, 2 times 2x will be 4x. 2 times 3 will be 6. So we have 2x minus 10 minus 4x plus 6. And the denominator will just be x minus 5 times 2x plus 3. Right? Because the denominator here and the denominator here are the same. We're just subtracting the two numerators. So then I'm going to do the 2x minus 4x gives you negative 2x, negative 10 minus 6, negative 16 over x minus 5 times 2x plus 3. I'll do that at the top of this board. There's one last simplifying step we could do. Oh, sorry, I forgot the is less than or equal to 0 here. Is less than or equal to 0. So the last simplifying step, we can factor out a negative 2 out of the top. We're left with an x plus 8. So we have that. Negative 2 times x plus 8 over x minus 5 times 2x plus 3 is less than or equal to 0. So now we can say, okay, when is the numerator 0? Well, when x is negative 8, the numerator is 0. Because x plus 8 is 0 when x is negative 8. Negative 2 is never 0. We don't have to worry about that part. The denominator is 0 when x is 5, because x minus 5 is 0. And when 2x plus 3 is 0, x turns out to be negative 2/3. If you're not convinced by that, you can do the 2x plus 3 equals 0. Oh, 3 over 2. Not 2 over 3. 3 halves, not 2/3. 2x plus 3 is 0. 2x is negative 3. Therefore, x is negative 3 over 2. So those are the numbers I'm going to be using here to divide up my number line. Negative 8, 5, and negative 3 halves. So negative 8 is a place where the top is 0, so I put a dot there. 5 is a place where the bottom is 0, so I put either an, actually I'll put an X, that's what I did before. This signifies this is a restriction on the domain. That is not going to be, again, this thing is sort of less than or equal to 0, and I'm trying to find a place where it's equal to 0. 5 is not going to be one of them. Same thing with negative 3 over 2. It's a place where the denominator is 0. So I put an X there. The intervals I get, negative infinity to negative 8, negative 8 to negative 3 over 2, negative 3 over 2 to 5, and 5 to infinity. I pick a test point in each interval. Here I could pick, let's say, negative 9. Here I could pick negative 5. Negative 5 is between negative 8 and negative 3 over 2. Again, you can pick negative 4, you can pick negative 7, you can pick negative pi if you wanted to. I wouldn't advise it, but you could. Here, between negative 3 over 2 and 5, you could pick 0. Here you could pick 6. Again, which test points you pick shouldn't affect your answer. Yeah. Okay. So I'm going to have to make some space. For the rest of my table. So the things I'm interested in x plus 8. I'm interested in x minus 5, and I'm interested in 2x plus 3. When are each of those things positive and negative? Okay, so if I take negative 9, negative 9 plus 8 is negative. Negative 5 plus 8, however, is negative 3, which is positive. 0 plus 8 is positive. 6 plus 8 is positive. If I take x minus 5, negative 9 minus 5 is negative. Negative 5 minus 5 is negative 10, which is negative. 0 minus 5 is negative. 6 minus 5, however, is positive. 6 minus 5 is 1. If I take negative 9, 2 times negative 9 is negative 18, plus 3 is negative 50. Still negative. 2 times negative 5 plus 3 is negative. It's negative 10 plus 3, which is negative 7. 2 times 0 plus 3, however, is positive. Because 2 times 0 is 0, 0 plus 3 is positive. 2 times 6 plus 3 is positive. So now I want to consider that whole thing. Negative 2 times x plus 8 over x minus 5, 2x plus 3. Is that thing positive or negative? Well, here on the top we have negative 2 times a negative number. That's going to give you a positive thing on the top. On the bottom we have negative 5, x minus 5, which is negative. 2x plus 3 is negative. That gives you a positive number on the bottom. A positive number divided by a positive number is positive. Here, we've got negative 2 times x plus 8. That's negative times x plus 8 is positive, gives you a negative number on the top. X minus 5 is negative, 2x plus 3 is negative. Multiply them together, it gives you a positive number at the bottom. Negative divided by positive is negative. Here, negative 2 times x plus 8 is a negative number times a positive number, gives you a negative thing on the top. X minus 5 times 2x plus 3 is negative times a positive, gives you a negative on the bottom. So here it's going to be positive. And the last one, we have negative 2 times x plus 8 is a negative number on the top. X minus 5 is positive, 2x plus 3 is positive number on the bottom, which means here the whole thing is negative. So now I'm asking, when is it less than or equal to 0? Well, it's less than or equal to 0 when it's negative. It's less than or equal to 0 when it's negative. It's not less than or equal to 0 when it's positive, but it's also equal to 0 there at negative 8. It's not equal to 0 at negative 3 over 2. It's not equal to 0 at 5 because those were zeros of the denominator. But negative 8 is 0 of the numerator, so it is equal to 0 there. So here the solution is, well, we're going to have the interval from negative 8 to negative 3 over 2. But we're going to have to put a square bracket on the negative 8 because that check mark there. And we're going to have the interval from 5 to infinity. And we're not going to have any square brackets on the interval from 5 to infinity. So that there is what that solution is going to look like. Any questions about this? Yes? Yes, this is rounded, sorry. It may look like a greater than symbol. That's supposed to be a rounded bracket. Yeah, thank you for asking. Taylor, right? Okay. Okay. Yeah. So I know I took a fair bit of time doing this. I wanted to make sure I got through this enough. This is sort of something that I know a lot of students find difficult, thinking about positives and negatives and stuff like that. It is also something that's going to come up over and over again if you take your calculus course. When you take your calculus course, it turns out you're actually not going to see a lot of these inequality symbols, but you will be doing the same thing. You'll be doing sign tables. You will be doing figuring out if things are positive or negative a lot. So I want to do lots of examples of this. And also because this is a short part of the question that's on the written assignment. Okay. So any other questions? Okay, if not, we're going to move on to section 2.1. Okay. And section 2.1 is on rectangular coordinate systems. I am sure that all of you have seen a lot of rectangular coordinate systems. It's like the x-axis and the y-axis, and like plotting the point 3, -4, and those sorts of things. So the reason I'm only going to spend 15 minutes on this section is because it should be really review for everyone. It should be stuff that you covered way back in grade 9 or grade 10. So again, I'm going to go over it because it's in the textbook, because there are questions on it, but again, this should be fairly straightforward review. So, the first type of rectangular coordinate system I can ask are things like locating points. How do you locate points in a rectangular coordinate system? So questions I can ask here are things like plot the points 2, 3, 3, -4, and -1, 7. How many people here feel super comfortable with this? And how many people feel, yes, good, I see lots of hands. Anyone here not okay with doing this? Again, this is like grade 9, grade 10 stuff, which is why, or maybe even grade 8, I don't remember the curriculum very well. So, but the point is that this should be easy, which is why I'm going to spend very little time on it. So what we're going to be doing in this course, and in most math courses, starting from again grade 9 or 10 on, is that when we're locating points, we use this thing called the rectangular coordinate system. It means you've got an x-axis and a y-axis. So you've got the vertical axis is called the y-axis, the horizontal one is called the x-axis. The points that they intersect is called the origin. The x-axis is positive numbers on the right, negative on the left. Y-axis is positive on the top, negative on the bottom, that sort of stuff. So, again, if you want to locate a point, you find the number x on the x-axis, the number y on the y-axis, draw two little lines, locate the point. X coordinate of the point is the x number, y coordinate of the point is the y number. So again, just to illustrate this, I am going to do an example. But again, because this should be like really basic review for most of you, I'm going to go do it fairly quickly. Okay. So, first thing for plotting points, draw the coordinate axes. And I always label them like 1, 2, 3, 1, 2, 3, -1, -2, -3, -3, -1, -2, -3. Again, the scale might not be just 1, 2, 3. It could be 10, 20, 30. It could be 100, 200, 300, depending upon how big the coordinates are. These ones will all fit in the 1, 2, 3 scale, so that's great. So the first one's at -3 and 1. So go to -3 on the x-axis, 1 on the y-axis. The point A is going to be there. B is at 3 and 1. So B is going to be here. C is at -2 and -3. It's going to be down there. D is at 0 on the x-axis, 3 on the y-axis, up here. And E is at 2 on the x-axis, -3 on the y-axis. So E is going to be down here. Again, these ones were, they planned this exercise so these things made a nice star. Anyone have any questions about this, how I did this? Again, I did this really fast. There is a question like this on the website. But again, it's stuff that folks should have covered like grade 9. So, any questions? Great. We'll move on to the next section. Okay. One thing to mention about rectangular coordinates is sometimes I'm not just going to talk about individual points, I'm going to talk about sets of points. Geometric objects are usually sets of points. They're usually more than one point. For example, this star is those 5 points together with all the points that are on each of those green lines. So, for example, any sort of equation or inequality will give you a set of points. So I just want to talk a little bit about each of these sets of points. So if we have x equals 4. X equals 4 means all the points which have x coordinate 4. Well, if you want to look at all the points that have x coordinate 4, there'll be 1 here, 1 here, 1 here, 1 here. Right? All these points have the same x coordinate. And if you put them all together, you get a vertical line. So x equals 4 turns out to be a vertical line. Now in part B there, we have x over y is less than 0, which means x over y is negative. Right? There's 2 different ways for a fraction to be negative. Either the top is negative and the bottom is positive, or the top is positive and the bottom is negative. So if I look on my coordinate plane, the question now is, where are those things true? Where is it true that x is negative and y is positive? Well, x is negative anywhere in the left-hand side, y is positive anywhere on the top-hand side. So this region that I'm filling in with green, that's where x is negative and y is positive. The second possibility, the second way for this fraction to be less than 0 is if x is positive and y is negative. It means we're on the right-hand side and the lower side, which gives you that area there. So that green region stated there, this is called a quadrant, together with this quadrant is that inequality. X over y is less than 0. So again, inequalities like this also have graphs that can be plotted. And when you plot an inequality, you fill in this region, you fill in this region. Any points in any of those 2 regions satisfy this. Similarly, if we have y is bigger than 1, the key thing is that's saying that the y-coordinate is above 1. So y-coordinate equal to 1 is this blue line here. Y-coordinate above 1 is anything above that. So that region that is shaded in blue, that region is y is bigger than 1. So again, equations give you lines or other sorts of what are called curves on the plane. Inequalities give you regions on the plane, things that can be filled in. Any questions about this example? Sorry, this is now example 2. How I located those regions. Okay. One thing to mention is when talking about the coordinate thing, there are these things that are called quadrants. Again, I mentioned that this green region up here is called a quadrant. This one down here is called a quadrant. Basically, when you draw these 2 axes, you divide up the plane into 4 quadrants. There's this quadrant, this quadrant, this quadrant, and this quadrant. This quadrant up here is called the first quadrant. This quadrant here is the second. This one here is the third. This one here is the fourth. So if you ever see a question in the textbook that talks about the third quadrant, it means this region of the plane. If it talks about the fourth quadrant, it means this region of the plane. If it talks about the second quadrant, it means this part of the plane. So again, just a little bit of terminology. This quadrant stuff will come up more once we start talking about trigonometry. You'll see a lot more of these quadrants, but I just want to mention it now because there are questions in this section that use that terminology. Any questions about this? Okay. What? Okay, that was a slide that got copied and pasted and shouldn't have been there. Ignore that slide. I'm going to delete it when I got a chance. That was a slide that I guess I copied and pasted from 1.6 and I was going to change and I didn't. So 2.1.2 deals with two formulas, what are called the distance formula and the midpoint formula. Distance formula is to find the distance between 2 points. The midpoint formula is to find the point that's halfway between 2 points. How many people here know those formulas already? Anyone? Know what those formulas? How many people here have not seen those formulas before and know that they have not seen them? Okay. Those formulas will both come up on the next slide, or sorry, next two slides. Again, these are two formulas that are very useful in a number of situations, and you should learn them. They will come up in calculus classes, so it is important to know these things. And again, in this course, my plan is to not give formula sheets because in calculus you won't have them. But I may change my mind about that. Okay. So the first formula is the distance formula. That's to measure the distance between 2 points. It looks like this. Seeing this, how many people have seen this before? How many people have not seen this before? No one raised their hand for not seen it, so probably you've all seen it before. Finding the distance between 2 points involves using the Pythagorean theorem. Basically measuring the distance between the x-coordinates, distance between the y-coordinates. I'm not going to show where this comes from with the Pythagorean theorem. I'm just going to sort of mention that this is the formula, and I'm going to show you an example of using it. So we want to find the distance between those 2 points. So if we're measuring the distance, we're going to have square root of x2 minus x1 squared plus y2 minus y1 squared. So the 2 points here are 5, 2, and 5, negative 2. The x1 is 5, the x2 is 5, the y1 is 2, the y2 is negative 2. So x2 is 5, x1 is 5, y2 is negative 2, y1 is 2. So 5 minus 5 is 0. Negative 2 minus 2 is negative 4. Negative 4 squared is 16. 0 plus 16 is 16. Square root of 16 is 4. So the distance between these 2 points is 4. One thing to mention is in this sort of problem, you don't really want to cancel out the square root and the square because the distance isn't negative 4, it's actually positive 4. You are allowed to cancel out that square root and that square, but only if you put absolute value signs around it. Right, I mentioned that you can cancel square root and square root only if you put absolute value signs if the thing inside is negative, which it is here. Okay. Any questions about distance formula? Okay. Midpoint formula is the next one. The midpoint is a point halfway between 2 points. To find the point halfway between, what we're going to do is we're going to take the average of the x-coordinates, average of the y-coordinates. You add the x-coordinates together, divide by 2. Add the y-coordinates together, divide by 2. Again, this formula, you should know, you should basically, well, you don't need, and this is one of these ones where I feel like I don't even need to memorize it. I just remember average of the x's, average of the y's. Or I can just sort of visualize it too. So if you can, if you're a very visual person, you can sort of like draw the 2 points and find the midpoint that way. But that is the formula you can use. So here again, we've got these same 2 points. So if I want to find the midpoint, I'm going to have x1 plus x2 over 2 and y1 plus y2 over 2. x1 plus x2 is going to be 5 plus 5. y1 plus y2 is going to be 2 plus negative 2. 5 plus 5 is 10. 2 plus negative 2 is 0. So we have 10 over 2 and 0 over 2, which is the point 5, 0. So again, if you want to graph this point, and that point, it'll turn out that that one is halfway between these. Any questions about example 4 here? Okay. The last thing we're going to talk about in this section is how to sort of solve problems involving the concept. Like finding all points on the x-axis which are at a distance 5 from the point 2, 3. How do we go about solving a problem like that? How many people feel like they've solved problems like this before? Let's see, two, a couple hands, 3 hands. How many people have not solved problems like this before? Let's see any hands for that. Again, this should be a review, but I'm just going to go over it to show you how to approach something like this. So the key thing is that if we know something about a point, we know what's called the form of the point. For example, the point from the x-axis is going to have a form a, 0. Its y-coordinate, if it's on the x-axis, its y-coordinate is going to be 0, right? In such a situation, if we know the distance of the point in question from some other point, we can use the distance formula to come up with an equation involving that variable a, and then solve the equation for a. So example 5 here. So here we want points that are of the form a, a. Basically, these points will have the same x-coordinate and the same y-coordinate. We want to find all the ones that are at a distance 3 from the point -2, 1. So here in example 5, the point 1, the first point is a, a. The second one is -2, 1. This is my x1, this is my x2, oh, this is my y1, this is my x2, this is my y2. So the distance is going to be square root of x2 minus x1. So -2 minus a squared. And then I'm going to have y2 minus y1, which gives you 1 minus a squared. And that distance we want to be 3. So we got 3 equals, now let's simplify this thing inside the square root. -2 minus a squared, I'm going to square the first thing, -2 squared is 4. I'm going to take 2 times the first thing times the second thing. 2 times -2 is -4, times -8 is +4. We get plus 4a, and then the second thing squared, which is a squared. Here if I expand this, 1 squared is 1, 2 times 1 times -a is minus 2a. A squared is a squared. So I get 3 equals square root, 4 plus 1 is 5, 4a minus 2a is 2a, a squared plus a squared is 2a squared. Now if I want to solve that equation, I'm going to have to do something. I'm going to have to square both sides to get rid of that square root. The left-hand side will become a 9. Here we'll have a 5 plus 2a plus 2a squared. Subtract 9 from both sides. 0 equals 2a squared plus 2a minus 4. I'm just rewriting this in a different order. Here I'm going to try to factor this thing. The first thing I can do in factoring is pull out a common factor of 2. Then I want to factor this. I want two numbers that add to give you +1, multiply to give you -2. That's +2 and -1. So either the first thing is 0, 2 is never 0. If the second thing is 0, that happens when a is -2. The third thing is 0, that happens when a is 1. So if a is -2, we get the point -2, -2. If a is 1, we get the point 1, 1. So those are the 2 points that are at a distance 3 from the point -2, 1. Any questions about this? So that's it for section 2.1. I'm now moving on to section 2.2. So I've got handouts for this guy as well. Here we go. Again, I'm about 10 minutes behind where I wanted to be today, so I may not be able to cover 2.2.3 today. Might just 2.2.1, 2.2.2. There's the first two sections. So, where's my 2.2 slides? Okay. So, section 2.2 is about graphing equations. Again, this stuff should be review for most of you. However, there might be some things in this section which are not review. For example, some of the stuff on symmetry, some people may not have seen that before. So I'm probably going to get through the first two sections of it today. Graphs of equations and symmetry of equations. Okay. So the first thing I'm going to talk about in graphs of equations is how to graph an equation like this, right? And there's two answers to this sort of question. You can either do it with your graphing calculator or you can do it by hand. How many people are confident doing this with their graphing calculators? How many people have not done this sort of thing with a graphing calculator before? You see, okay, I see one. I will then quickly go over how to use a graphing calculator, but I'll do it at the end. And then the other thing, how many people have graphed something like this by hand before? How many people have not graphed something like this by hand before? Okay, a couple people for that too. So again, I'm going to go over both. It turns out at this point there's no fancy tricks for doing either of those. The graphing this thing by hand is, I'm going to be sort of doing it the long and hard way for now. Later on we'll learn some easier ways of graphing these sorts of things by hand. But for now we're going to be doing the long and hard way. Now what's the long and hard way of graphing things by hand? What the long and hard way is creating what's called a table of values. Some people call these T-charts. If you've ever heard the word T-chart, it's the same thing. I never use that word, so the like technical mathematical word is table of values. The key thing is you pick a bunch of values for x, plug them in, and find a bunch of values for y. And then you've got a bunch of points, you can plot them, connect it off. Again, this is the long and hard way of doing it. There are easier ways of doing this we'll come up later in the course. The other thing that a lot of people have not done before is graph equations that look like x equals something. Like if you had x equals y squared or x equals y cubed, you're going to do exactly the same thing, except rather than picking a bunch of values of x, plugging those in to find values of y, you're going to pick a bunch of values of y, plug those in to get values for x. So you sort of do it backwards from the way you're used to doing it. So just to give an example of this, I'm going to do example 1 here. So here we have the equation x equals 2y squared minus 4. So in this case, since x is a function of y, I'm going to pick the values for y first, then plug those in to get the values for x. So usually the easiest values to use are -2, -1, 0, 1, and 2. I will usually use those 5 when coming up with graphs, but there are other ones you could do. You can pick whatever you want here. These are usually the easiest. If you take -2, -2 squared is 4, 2 times 4 is 8, 8 minus 4 is 4. I take -1, -1 squared is 1, 2 times 1 is 2, 2 minus 4 is -2. Take 0, 0 squared is 0, 2 times 0 is 0, 0 minus 4 is -4. Take 1, 1 squared is 1, 2 times 1 is 1, 2 times 1 is 2, 2 minus 4 is -2, and if we take 2, 2 times 2 squared is, so 2 squared is 4, 2 times 4 is 8, 8 minus 4 is 4. So that gives you those values there. And once you have a table of values like that, you can sketch the graph by just plotting points. So, when x is 4, y is -2. So we get a point here. When x is -2, y is -1. When x is -4, y is 0. When x is negative 2, y is 1. And when x is 4, y is 2. This is 4, 2. This is 4, negative 2. This is 2, 1. This is 2, negative 1. And this point here is negative 4, 0. And if we connect the dots, we get a curve that looks like that blue line there. That's what the graph of x equals 2y squared minus 4 is going to look like. Any questions about what I did in example 1 here? Okay. One thing to mention, again, graphing calculators are very useful tool for graphing equations. However, the graphing calculator, as far as I know, you cannot use to graph something with an x equals. You can only use it to graph something with a y equals. So if now there may be like programs you can get for your graphing calculator which can do that. I mean, certainly not beyond the technological capabilities of that calculator. Just, it's not easy to do that. Okay. Again, at the end, I'll sort of show quickly how you would graph something with a graphing calculator. Any questions about how I graphed this thing by plotting a table of values? Okay, intercepts. Any graph has two important properties. They're called the x-intercept and the y-intercept. The x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. If you want to find the x-intercept, you set y to be 0. Again, because if it's on the x-axis, the y-coordinate is 0. To find the y-intercept, we set x to be 0. Because on the y-axis, the x-coordinate is 0. So, oh yeah, example 2. So I'll first find the x-intercept and y-intercept here, and then I'll show you how to use the graphing calculator to sketch the graph of this guy. So here the function is y equals negative x cubed plus 1. So the first thing, if I want to find the x-intercept, I set y to be 0. So I get 0 equals negative x cubed plus 1, and then I solve this thing for x. Add x cubed to both sides, I get x cubed equals 1. Take the cube root of both sides, I get that x equals 1. Again, because it's a cube root, because it's an odd root, I do not have to put a plus or minus on the 1. If it was x squared equals 1, I get x equals plus or minus 1. If it's x to the 6 equals 1, I get x equals plus or minus 1. Again, because those are even roots. So, the x-intercept here is the point 1, 0. Just to mention, intercepts are points, they are not just numbers. In the book, they oftentimes write the answer as like x equals 1 as the x-intercept. On WebAssign, they want you to type it in as point 1, 0. Just to mention that in general, this is the better form to put intercepts in. It actually is 1, 0, not just 1. Okay. If I want to find the y-intercept, I set x to be 0. So then I get y equals negative 0 cubed plus 1, which gives me 1. So the y-intercept there is 0, 1. X is 0, y is 1. Now, if we sketch the graph with a graphing calculator, we can see where these things appear. So if you're sketching the graph with a graphing calculator, the key thing to use is this button up here, which is labeled y equals. So you click on that button, you see a bunch of different equations. y1 equals this, y2 equals that, y3 equals whatever. And so then, maybe I want to clear my y1, and I'm going to type in, what is it? Oh, great, where did it go? Here. Negative x cubed plus 1. So I go back to my graphing calculator, and I type in negative x to the power of 3 plus 1, hit graph. And there we go, it constructs a graph. And here you can see the x-intercept. It crosses the x-axis at point 1, 0. It crosses the y-axis at point 0, 1. That's sort of basic, doing this sort of thing with a graphing calculator. Again, if it's y equals something, the graphing calculator will always work. If it's x equals, not so much. Okay. So the last thing I'm going to talk about today is symmetry. 2.2.2 on symmetry of equations. And what we're going to talk about is how do we figure out if you've got an equation like this, if it's going to be symmetric to the x-axis, the y-axis, or the origin. Those are three types of symmetry that graph's going to have. This one, you'll notice that I have down here, this graph is symmetric. You reflect it vertically, the graph looks the same. This is called symmetry with respect to the x-axis. How many people have figured out symmetry algebraically before, like without using a graphing calculator, figuring out the symmetry? Anyone? Okay, you see one. Again, this is something, I think it may not be in the current high school curriculum. For certainly folks who took, I think you took Math 196, right, Kat? Yeah, Math 196 it should be covered, but yeah, high school stuff sometimes isn't, so yeah. So, there's three types of symmetry a graph can have. So we can actually test algebraically using the equation which type of symmetry it's going to have. It's symmetric with respect to the x-axis. If you reflect it along the x-axis, you get the same graph. So this one's symmetric with respect to the x-axis. One way of testing if it is symmetric with respect to the x-axis, replace x with negative x, and then simplify. If you get back the same equation you started with, it is symmetric with respect to the x-axis. It's symmetric with respect to the y-axis, if you can reflect it along the y-axis and get the same graph. This situation, we replace y with negative y and see if we get back the same equation. Wait a second. No, I reversed those. This is supposed to be y with negative y, this is supposed to be x with negative x. So, again, because in this example, if I want to switch these two equations, I'm taking the y coordinate to negative y. And this is symmetric with respect to the x-axis. So these two, this is a mistake and that's a mistake. And last type of symmetry, it's symmetric with respect to the origin. If you can rotate it 180 degrees about the origin, about this point here, and it gives you the same graph. And if you're doing that, you replace x with negative x and you replace y with negative y. And see if you get back the same equation you started with. So I'm going to do a couple examples of this, and that's the last thing I'm going to do in class today. So, a couple things to mention about testing for symmetry before I do the examples. First thing is that you have to test for each type of symmetry separately. Just because it's not symmetric with respect to the x-axis does not mean it is going to be symmetric with respect to the y-axis. Even if it is symmetric with respect to the y-axis, it still could also be symmetric with respect to the x-axis. So you do have to do 3 separate tests for symmetry for each graph. Yeah. So, in example 3, we want to determine which types of symmetry will be present in this graph here. So here we have the function x equals 2y squared. Negative 2y squared. So first I'm going to test for symmetry with respect to the x-axis. So here I'm going to replace y with negative y. When I do that, I get negative 2 times negative y squared. If I take negative y squared, negative y times negative y, that gives me y squared. Right? A negative number squared gives you a positive result. This equation is the same as the equation we started with, which means this one is symmetric with respect to the x-axis. This thing does have x-axis symmetry. Now if we want to test for symmetry with respect to the y-axis, here we have to replace x with negative x. When we do that, we get this. Negative x equals negative 2y squared. If I simplify that, basically I can divide both sides by negative 1. I just get x equals 2y squared. This is not the same as the original equation. It's not the same as the thing we started with, so this thing is not symmetric with respect to the y-axis. And lastly, I can do symmetry with respect to the origin. Here I replace x with negative x, and I replace y with negative y. When I do that, the equation will become negative x equals negative 2 times negative y squared. Right, so replace the x on the left-hand side with the negative x. I replace this y here with the negative y. Negative y squared is just y squared. So I get negative x is negative 2y squared. I get rid of the negative signs on both sides. I get x equals 2y squared. I'm not sure why I switched colors there. That hopefully is not too confusing. And this guy is not the same as the original equation. So since it's not the same, this thing is not symmetric with respect to the origin. Sorry, I dropped my pen. Okay. Any questions about example 3 here? Again, test for symmetry with respect to the x-axis, we replace y with negative y. Test for symmetry with respect to the y-axis, we replace x with negative x. Test for symmetry with respect to the origin, we do both. And if we get back the same equation we started with, it is symmetric. If we get back a different equation, it's not symmetric. Okay. Last example for today is example 4. Here we have y equals 1/2 x cubed. So we have a different example, but it's the same thing. Determine what type of symmetry it has or does not have. So there's the equation we start with. So first, we test for symmetry with respect to the x-axis. We replace y with negative y. We get negative y equals 1/2 x cubed. If we wanted to, we could multiply both sides by negative 1 to get that. Y equals negative 1/2 x cubed. Again, these guys are not the same. So this thing is not symmetric with respect to the x-axis. If we test for symmetry with respect to the y-axis here, we're going to replace x with negative x. I get y equals 1/2 times negative x cubed. Now if we take a negative number and cube it, we get another negative number. So this is 1/2 times negative x cubed, which is the same thing as negative 1/2 x cubed. Again, that guy is not the same as what we started with. We started with y equals 1/2 x cubed. Here we got y equals negative 1/2 x cubed. So again, this one is not symmetric with respect to the y-axis. Now, if we want to test for symmetry with respect to the origin, we've got to do both substitutions. We replace x with negative x, and we also replace y with negative y. So we'll get here negative y equals 1/2 times negative x cubed. Negative number cubed gives you a negative number. So we get negative y equals 1/2 negative x cubed. 1/2 times negative 1x cubed is negative 1/2 x cubed. Now, if you have a negative number on both sides, we can always multiply or divide both sides by negative 1 to get rid of it. So if negative y is negative 1/2 x cubed, y is 1/2 x cubed. And this guy is the same as what we started with. Right? Y equals 1/2 x cubed is the same as the thing we started with back there. So this guy is symmetric with respect to the origin. Sorry, when I'm writing this, I'm using WRT instead of the words with respect to. The only reason is really to save space at the board. That's what's going on there. And again, you don't even really need to write full sentences in these sorts of things as long as you say like symmetric origin, not symmetric y-axis. I'll understand what's going on. Okay. Any other questions before I move on to the group problems for today? Okay. So, we're not going to go 2.2.3 today. So I'm just going to pull out the group problems. So those are the two group problems for today. We want to find the distance between 2 points and the midpoint, again using distance formula, midpoint formula. And then sketch the graph of this thing, find all x and y intercepts, test the equation algebraically for symmetry with respect to the x-axis, y-axis, and the origin. So the first one's a 2.1 question, the second one's a 2.2 question. Again, I've got muddiest point cards to give out. If folks have anything in today's class they found particularly confusing, you want me to go over at the beginning of the next day's class, feel free to write it on the card, and I will go over it at the beginning of next class. If you don't write anything, that is also totally okay. There's a box for cards. And if anyone has answers they want me to check, feel free to put up your hand and I can go check them. Sorry.
Push the button.
Oh, shoot. Don't? Oh, I know what I did. I switched it to DVD VCR because it was still on. Great. There we go. PC. Or sorry, it'll be back in a second. How many people have gotten the first question at this point? How many people have not gotten the first question? Okay, I'll give a little bit more time. I want to show the answer to the first question today because it's fairly straightforward. Okay, I can go ahead? Okay, awesome. The second one, I think I'll wait until maybe the next class and give the solution to. Oh, great. It's still not BC. Anyways. So the first one we have the points A, which is negative 4, 7, and B, which is 0 and 8. There we go. So if you want to find the distance between them, we take the square root of x2 minus x1 squared plus y2 minus y1 squared. So right, use that distance formula. 0 minus negative 4 is 0 plus 4, which is 4. 8 minus 7 is 1. Great, it's still doing a blue screen. It's on. Four squared is 16. 1 squared is 1. So we get the square root of 17. Note that we pretty much just leave our answer like this. We cannot simplify square root of 17. And unless I specifically say so, I don't want you a decimal approximation for this. I want the square root of 17. Because square root of 17 is what's called an exact answer. If I want to find the midpoint, the x-coordinate's always x1 plus x2 over 2. Y-coordinates y1 plus y2 over 2. So we have negative 4 plus 0 over 2. And we have 7 plus 8 over 2. Negative 4 plus 0 is negative 4. Negative 4 divided by 2 is negative 2. 7 plus 8 is 15. 15 divided by 2 is 7.5. Now 7.5 is fine as a decimal because it's an exact decimal. It doesn't keep going and then get cut off by your calculator. It stops. It is just exactly 7.5. If you want to write it as 15 over 2, that is also correct. And I still don't know why this freaking projector's not working. Let's see if this... Great. I'm sorry, I must have done something to the projector. Anyway, so you have 2 minutes left. So again, if you have the second question copied down, that's great. If not, hopefully it'll be back up in a second if you want to copy it down. And then, yeah. And I'll go over how the second question works at the beginning of the next class. Does anyone have money to point cards to open the box? It's still not working. What the frick? Oh, hey, there it is. So anyways, this is the last question. Oh no!
It was -8, yeah.
Okay, there we go. I copied it down wrong. Anyways, so the answers to these questions are incorrect because I copied down the numbers wrong, but just use the same formulas, put the right answer in. Yeah, I know, this is what happens when the projector dies and then I don't notice, and then, yeah. Anyways. I'll change it later. Or if anyone really wants to check, but, yeah. Yes?
On Friday, I couldn't find my binder, and I wanted to get a scan through the class after, and found a reddish binder.
I did not find one.
Okay.
I didn't look. I don't actually generally look
fair
at
enough.
things. I look for that. So check lost and found, exactly. Sometimes it's even still in that classroom. So there's a possibility that it just hasn't been used by anyone. Yes.
Yeah, I was wondering if I just find like the online
the 1% thing.
Yeah. Yeah, no, for sure. That should definitely work. Again, at this point, you've already missed 2 assignments.
Oh, yeah.
Can we have assigned assignments?
Oh no, I've done them because of the
Oh.
free trial.
Oh, you had the free trial. Great, good, good. I was worried because I was like, well, yeah, I mean,
Yeah, it just ended like yesterday, so I'll
okay, good.
buy it.
Yeah, so no, if you buy that, that will work. Yeah, I was gonna say, like, that's, to be honest, in the short term, that's the most important thing. I mean, and if you do that, then it's best to get a used copy of the textbook anyways, because then otherwise you're paying twice for the code or whatever.
Yeah.
Yeah.
And then I was doing the assignment.
Yeah.
I was wondering if I did part A right, like factor.
Not, no. No, that's not, you're close. You've got some correct methods in there, but the answer's not correct. So, yeah. So look, yeah, maybe look through the examples of factoring other things that look like that.
Okay.
And try, or, yeah. Actually, and in fact, I can actually tell you the mistake is in that first step. Yeah.
We actually have, I also have a question, like, factoring the bottom here, that's when I like plug into my calculator,
Yeah.
and it says here that there should be 3 linear,
Yeah.
3 one, and 1 quadratic. When I have in my calculator, it actually only crosses through x 3 times, not 4 times.
Exactly.
So
The
how is that
quadratic one
possible?
does not cross through x.
Yeah,
Right, there are quadratics which don't cross the x-axis.
yeah,
Like
but
x
there
squared
isn't one
plus
that like goes and touches either, like when I grab
No,
it.
no, no, like x squared plus 3 does
Yeah.
not ever cross the x-axis or even touch it,
Yeah,
right?
so it doesn't touch it?
It doesn't touch it, no, x squared plus 3. Let's look at the graph of x squared plus 3. Again, I think this is part of it, is that you're definitely, I mean, your thoughts are great. Like, your thoughts about this are great. That's what the graph of x squared plus 3 looks like. It never touches the x-axis. So what this tells you, if it only touches the x-axis 3 times, is that whatever quadratic one you get, it's going to be something like this, that never touches the x-axis. So yes, you have actually learned something about that quadratic.
So am I kind of going about it the wrong way? Because I wasn't really sure what to do.
Well, what did I say you do when you have 4 terms? There's something specific I said you should always try when you have a polynomial with 4 terms. Check the notes. Yeah. Yeah.
Do you want to make it equal to 0? And then,
Making it equal to 0 won't help you factor it. Factoring it will help you make it equal to 0. So, yeah, making it equal to 0 is not going to really help. The only time that'll help the factoring is if you use a quadratic formula, which won't work here because it's not quadratic. It's got
so is there any like good examples that I could like look at, like steps,
Just
like other
check the
methods?
methods of factoring I've talked about, right? I talked about I talked about taking out a common factor. I talked about factoring by trinomials. There's 3 terms, right? That's the add and multiply rule. I talked about grouping, and I talked about using formulas. So one of those 4 things will work.
All right.
And just go through and check the notes, check which one of those you think will work here.
All
Or
right.
if you know those methods in your head, think about, okay, which one's likely to apply.
If I do some work on it, then like can I bring it into your office hours on Thursday?
Yeah.
You can just
Certainly,
check it
I can tell you where you made mistakes.
Okay.
For sure, I can do that much.
All right.
And I can give you sort of like places to look for other ones. But yeah, just look through the notes on factoring and check, okay, which of those methods that I taught will apply here.
All right. Thanks a lot.
Yeah.
Does it cancel some or no?
Yeah.
To do that.
Okay. Well, what's different between this example and the example that you did? There is something very different between those 2 examples. So you're using the right method, but you made a mistake in going from the first step to the second step. So what's different between this here and this here? Look at this. Look at the way these are written. Something very different between here and here. Exactly. You have to take something out of there. What did x squared and minus 4 have in common? Well, there's one thing it has in common. It's very simple. 1. You have to take that 1 out. Is it a positive 1 or a negative 1? Exactly. There is a difference. Because here these 2 things are multiplied together. Here these 2 things are subtracted. If you put a plus 1 in there, they're no longer being multiplied, they're then being added. Right? Which is like these guys being subtracted. Right? Whereas this is not this times this. Right? There's this plus sign there that you've sort of just dropped out of, you've forgotten about this plus sign. And if you put the plus 1 in there, that plus sign will reappear. Does that make sense? Yeah. So that's the key thing going on. Is they've written this as multiplication, but it should have been addition. Yeah.
And And then like, I did the restrictions already.
Yeah, well, if you factor this, there should be, are those the only restrictions? Yeah, those are not, those are not correct restrictions.
Okay.
That's because the factorization, if this factorization was correct, these would be the correct restrictions.
Okay.
But yeah, if you fix this, you'll find the restrictions are slightly different.
When you're adding them, is that like just like the last step then?
No, like again, once you have this thing minus this thing, you've got the same thing in two different terms. You've got 5x squared times this thing minus 20 times this thing. This thing is now a common factor. And then that thing will come out, and then you take what's left, right? And again, you didn't do that step. You didn't take out the common factor between those two terms. So again, this grouping has two steps. First, look for common factor the first two, common factor the second two. If those two things are the same, then take it out as a common factor, see what's left. Yeah. And then you might have to factor further. Right? Like that's the other thing too, is that, again, yeah.
Okay, I get that now. And then for part C,
Yeah.
it's like solve the equation.
Yeah.
I would just like, that equals 0, right?
Yep,
'Cause when-
perfect. Because if you multiply both sides by the thing on the bottom, it'll get rid of it.
And then I'm just like, I don't know what to do next because I'm kind of,
Look for examples in the notes where I did equations like that.
okay.
I did do some that were like that, that had like 2/3 powers and stuff in them, so yeah. Yeah.